Identify the nature of the solution. Combining a weak acid, HNO2, with its conjugate base, provided by the soluble ionic salt KNO2, which dissociates completely into K to the power plus and number 2 to the power negative, creates an acidic buffer solution. Understand how a buffer operates. A buffer resists changes in pH because it contains both a weak acid component to neutralize added base and a weak conjugate base component to neutralize added acid. Identify the chemical stress introduced. Adding a few drops of the strong acid HCl introduces a supply of free hydrogen ions, H to the power plus, into the aqueous system. HCl gives H to the power plus plus Cl to the power negative. Determine the neutralization pathway. To prevent the pH from dropping significantly, the added H to the power plus ions must be absorbed. The basic component of our buffer, the nitrite ion, number 2 to the power negative, will react with these incoming H to the power plus ions to form the weak, poorly dissociating nitrous acid. H to the power plus plus number 2 to the power negative gives HNO2 because the strong acids H to the power plus ions are bound up into weak acid molecules. The overall concentration of free hydronium ions in solution is kept nearly constant, which stabilizes the pH. This identifies option D as the correct representation. The correct answer is option D. H++ and O2- gives H and O2.